In this section, we are going to talk about solving quadratic equations by one more method, and that method is called the method of quadratic formula. Quadratic formula is also known as shreedharacharya's rule, which suggests that this method was actually found out by Shreedharacharya. This method relies heavily on completing the square method. So we are going to derive the formula using the concept of completing the square method. So let's assume that we have a quadratic equation which is ax square plus bx plus c equal to 0, right? Assume that this is the quadratic equation, and now this is the general form of the quadratic equation, and now what we are trying to do is we are trying to solve for the variable x, right? So what we will now do is we will first of all divide the complete equation by a, because if you remember we always wanted the coefficient of x squared to be 1. So let's divide throughout by a. So dividing throughout by a, we get, so let's divide everything by a. Ax square by a becomes x square, and bx upon a becomes bx upon a, and c divided by a becomes c upon a is equal to 0. And now we are going to use the same tricks as we used in completing the square method. This becomes x square plus 2 times x times, and now let's see what term should come over here. So I have b upon a, and I know that I should be multiplying the denominator by 2. So this becomes b divided by 2a, and plus c by a is equal to 0. So this therefore becomes x square plus 2 into x into b upon 2a. I think we have found out our b. Our b actually is b upon 2a. So let's add b upon 2a the whole square to both sides of the equation. And of course I have a c over here. Now the first 3 terms that you notice here, these 3 terms, they form a complete square. So let's write this as x plus b upon 2a the whole square plus c is equal to, and let's square this side. This becomes b square by 4a square. Now the positive c shifts to the negative side and it becomes negative c. So x plus b by 2a the whole square is equal to b square, and of course this should have been c by a, by the way. I think we missed the divided by a here because there's a divide by a in the second step here. So this is c divided by a, and now I would shift that c by a to the other side. So it becomes b square by 4a square minus c upon a. Now the left hand side is of the form x plus b by 2a the whole square is equal to, what is the LCM now? The LCM of these two terms is 4a square. This is going to be 4a square. Now b square actually has 4a square as the denominator. So I would simply multiply b square by 1 and minus this a needs to be converted into 4a square. That means I should multiply it by 4a. So this becomes 4a multiplied by c. And therefore I can say that x plus b upon 2a is equal to square root of b square minus 4ac divided by square root of 4a square. So square on one side has become square root on the other side, And we also know that a square root will have a positive or a negative answer. Therefore, I can now continue and find the value of x. So let's now try to find the value of x. So x plus b by 2a, or rather now I can shift the b by 2a to the other side. So x is equal to minus b by 2a. You will notice that b by 2a has a positive sign here. So when you shift it to the other side, it becomes minus b by 2a plus or minus under root of b square minus 4ac divided by root of 4a square is 2a. And therefore x is equal to, the denominator is 2a, right? The denominator is now 2a and the numerator is minus b plus or minus under root of b square minus 4ac. And therefore the roots of the quadratic equation are, x equals minus b plus under root of b square minus 4ac, the whole divided by 2a, or x is equal to minus b minus under root of b square minus 4ac, the whole divided by 2a, right? These are the two roots of the quadratic equation. So let's go through the process one more time. I had ax square plus bx plus c equal to 0. I divided the whole equation by a. This was done because I wanted the coefficient of x square to be 1. So I got x square plus bx upon a plus c upon a equal to 0. This is the first step. Now I decided to complete the square. So in this process, I wrote the middle term as 2ab. So it is 2 into x into b divided by 2a and plus c by a equal to 0. Now that I have figured out my b, so if you notice the value of b that we got is b upon 2a, right, after completing the square. So because the second term is b upon 2a, it means that I need to add b upon 2a the whole square to both sides, which was done in the third step. Then I shifted the c upon a term to the other side. So I got these three terms together made up x plus b by 2a the whole square plus c upon a is equal to b square by 4a square. Then I shifted the c upon a term to the other side. So x plus b by 2a the whole square is b square by 4a square minus c by a. The LCM is 4a square, which means this term, this c by a term, needs to be multiplied by 4a, which is what I did here. So I got b square minus 4ac upon 4a square. The square shifts to the other side as square root. So x plus b by 2a is plus or minus under root of b square minus 4ac by square root of 4a square, which is 2a. Yeah. So therefore x becomes minus b by 2a plus or minus under root of b square minus 4ac by 2a. The LCM is now 2a, right? So the denominator is 2a and the numerator is minus b plus or minus square root of b square minus 4ac upon 2a. The roots of the quadratic equation therefore are minus b plus root of b square minus 4ac by 2a and minus b minus square root of b square minus 4ac upon 2a. So this gives us two different roots for a quadratic equation, and the advantage of using this particular equation are manifold. First of all, sometimes you cannot split the middle term really well, and using the completing the square method could be a really long process, which is why this particular method gives you the answer immediately, right? And that is why this particular formula is very useful when you want to calculate your quadratic equations quickly. Sometimes the factorization is possible, but you are not able to figure out the right way to split the middle term, which is again where this particular formula comes to our rescue. And formulas are generally very good when it comes to machines. So for example, if you wanted a computer to solve a quadratic equation for you, then if you can feed the computer this particular formula, then it can definitely give you the roots of the quadratic equation. So in summary, whenever you have a quadratic equation and if you know the values of a, b and c, then it is very easy to calculate the roots of this quadratic equation. So let me again pause for a minute. I believe you should go through this particular theory that was presented on the board, and then we will learn how to solve quadratic equations using the quadratic formula. And this quadratic formula presents some interesting facts about the nature of roots, which also can be explored. So pausing for a minute or so. So now let us solve a few quadratic equations using the quadratic formula. So consider these two quadratic equations. We now want to solve these quadratic equations using the shreedharacharya's formula. So first thing that we need to do for using the formula is to note down the values of a, b and c. So I would say comparing the given equations with ax square plus bx plus c equal to 0. It gives us a is the coefficient of x square, so a is 1, b is the coefficient of x, so b is minus 4, and c is the constant, which is equal to 2. Therefore, I can say that x is equal to minus b, which is minus of minus 4, plus or minus under root of, okay, before I do the substitution, let me write the formula. That would be a better idea. So the formula was minus b plus or minus under root of b square minus 4ac divided by 2 times a, right? So let us now substitute the values. Minus b, that's minus of minus 4, plus or minus under root of b square, that's minus 4 the whole square, minus 4 into a into c, the whole divided by 2 times a. So this becomes 4 plus or minus under root of 4 square is 16, 16 minus 8 divided by 2. That is equal to 4 plus or minus under root of 16 minus 8 is 8 divided by 2. So this can be written as 4 plus or minus root 8 can be written as 2 root 2, right? We know according to surds, 8 can be split as 4 into 2, and 4 square root of 4 is 2, so it is 2 root 2 divided by 2. Now I can pick 2 out as common from the numerator, so it becomes 2 times 2 plus or minus root 2 divided by 2. The 2 cancels. Therefore, I can say that the roots are 2 plus root 2 and 2 minus root 2. These are the two roots of the given quadratic equation, right? So you will notice that it is so easy to calculate the roots. If you know the value of root 2, Now you can substitute the value of root 2 and find the actual roots of the quadratic equation. So the key here is once a quadratic equation is given to you, you should always find the values of a, b and c, and then it is simple substitution to find the roots of the given equation. So now let us solve the second one using the quadratic formula. So let's take a look at this equation. We have 3x square plus 2x minus 1 is equal to 0. A is equal to 3, then b is the coefficient of x, so b is 2, and c is the constant, which is negative 1. So what was the quadratic formula? The quadratic formula was x equals minus b plus or minus under root of b square minus 4ac the whole divided by 2a. Therefore, x is equal to minus b, which is minus 2, plus or minus under root of b square, that's 2 square, minus 4 into 3 into minus 1, the whole divided by 2 times a is 3. So this is equal to minus 2 plus or minus, let's calculate this now. 2 square is 4, negative of negative is positive, so 4 3s are 12 divided by 6, which is equal to minus 2 plus or minus root 16 divided by 6. Therefore, I can say the roots are minus 2 plus root 16 by 6 and minus 2 minus root 16 by 6. Now root 16 is 4, so this is minus 2 plus 4 by 6 or minus 2 minus 4 by 6. Minus 2 plus 4 is plus 2 by 6 is 1 by 3, and minus 2 minus 4 is minus 6 by 6 is minus 1. Therefore, the roots of the quadratic equation, of the given quadratic equation are 1 by 3 and minus 1. Now let's quickly check if our answer is correct. Just like simultaneous equations, you can always check if the solution of the quadratic equation is right. You can always substitute the value of x in the given equation and check whether it satisfies your equation or not. So let's do a quick check. So the left hand side of the equation is 3x square plus 2x. So 3x square plus 2x. Let's substitute the value of x. X is 1 by 3. So 1 by 3 the whole square plus 2 into 1 by 3. So this is 3 into 1 by 9, which is 1 by 3 plus 2 by 3, and 1 by 3 plus 2 by 3 is 3 by 3, which is equal to 1, and that matches the right hand side. Similarly, I have 3x square plus 2x, that is 3 into negative 1 the whole square plus 2 into negative 1. Now negative 1 the whole square is positive 1, so 3 into positive 1 is 3, and this is 3 minus 2, which is equal to 1. So you will notice that both the values of x definitely satisfy the given quadratic equation, and hence our answer is right. So let us go ahead and solve a few more questions based on the quadratic formula. So I wish to solve the following quadratic equations using Shreedharacharya's rule. So let's take a look at the first one. So I can say that the given quadratic equation is x square plus 2x minus 7 equals 0. You will notice that to use the quadratic formula, you always have to convert this into the standard form so that you get the values of a, b and c. So I can say comparing the given equation with the standard form, which is ax square plus bx plus c equal to 0, gives us a is equal to 1, a is the coefficient of x square, which is 1, b is the coefficient of x, which is 2, and c is the constant, which is minus 7. So what was the quadratic formula? So using quadratic formula now, we get x equals minus b plus or minus under root of b square minus 4ac divided by 2a. So this plus or minus basically means that I have to include plus in one root and minus in the second root. So plus or minus basically means I have to include both the signs for finding the roots. So x therefore equals minus b. So let's substitute that. Minus 2 plus or minus under root of b square, that's 2 square, minus 4 into 1 into minus 7 divided by 2 times a, that is 2 times 1. So therefore x is minus 2 plus or minus under root of 2 square is 4, minus of minus is plus, and 4 sevens are 28 divided by 2. Therefore x is equal to minus 2 plus or minus under root of 32 divided by 2. Now we know how to deal with root 32. I can write this as x equals minus 2 plus or minus root 32 can be written as 16 2s are the whole divided by 2. So that equals minus 2 plus or minus 16 can jump out of the square root as 4. So this is 4 root 2 divided by 2. And now I can say that x is therefore minus 2. Let's split the terms now. So minus 2 plus 4 root 2 by 2 and minus 2 minus 4 root 2 by 2. Now I can divide. Minus 2 by 2 becomes minus 1 and 4 root 2 by 2 becomes 2 root 2. So x is therefore minus 1 plus 2 root 2, or minus 2 by 2 is minus 1 and minus 4 by 2 is minus 2. So it is minus 1 minus root 2. Therefore the roots are, now you can write the roots as these two roots individually, or you can also write it as minus 1 plus or minus 2 root 2. Though this form is the preferred form. So these are the actual roots of your quadratic equation. So let me pause for a minute for you to take a look at what all was done, and then we will continue. Okay, moving on to the next question. So consider the second equation now. It's given that 3x square plus 8x plus 3 is 0. So again, comparing the given equation with ax square plus bx plus c equal to 0 gives us a is the coefficient of x square, so a is equal to 3. B is the coefficient of x, it is equal to 8. And c is the constant, which is equal to 3, right? So now using these values, I can substitute them in the formula. 8's minus b, that's minus 8 plus or minus under root of b square, that's 8 square, minus 4 into a into c, the whole divided by 2 times a, that's 2 times 3. So therefore this becomes minus 8 plus or minus under root of 8 square is 64 minus 4 3s are 12, 12 3s are 36, the whole divided by 2 3s are 6. So this equals minus 8 plus or minus under root of 64 minus 36 is 28 divided by 6. So now what I can do is I can convert this 28 into 4 7s are. So x is therefore equal to minus 8 plus or minus under root of 4 into 7 divided by 2 times 3, that's 6. So x is equal to minus 8 plus or minus, this is 2 root 7 divided by 6. I can take a 2 common from the numerator, so it's 2 times minus 4 plus or minus root 7. So I've taken the 2 out as common, divided by 6. I can cancel out 2 and 6 3 times. Therefore, I can say that the roots are the roots are x equals minus 4 plus root 7 by 3 and minus 4 minus root 7 divided by 3. These are the two roots of the given quadratic equation. So you have to be very careful with the signs, especially when you are trying to find the 4ac term. If your a and c are negative, then you have to be very careful while calculating the value of that 4ac term, because there's a negative sign associated with it. So be very careful while noting a, b and c and substitute them appropriately. Again, waiting for a minute before we move on to the next one. Okay, moving to the next question. So let us consider the next problem now. We have 5m square plus 5m plus 1 equal to 0. So comparing this with, I believe now instead of ax square, we should have am square plus bm plus c. So let's replace it. Am square plus bm plus c gives us, a is the coefficient of m square, which is 5. B is the coefficient of m, which is also 5. And c is the constant, which is 1, right? And therefore, using the quadratic formula, so now in this case, because the variable is m, I would write m is equal to minus b plus or minus root b square minus 4ac divided by 2a. Therefore, m will be equal to minus b is going to be minus 5 plus or minus under root of b square, that's 5 square, minus 4 into a into c, the whole divided by 2 times a. So that's going to be minus 5 plus or minus under root of 5 square is 25. So 25 minus 20 divided by 10. So that is equal to, m is equal to minus 5 plus or minus root 5 divided by 10. And therefore, in this case, I cannot take out a lot of terms out as common. So I'm just going to leave the answer as it is. So I will say the roots of the quadratic equation, are therefore minus 5 plus root 5 by 10 and minus 5 minus root 5 divided by 10. Again, now I can decide to split these terms. So what I mean is, I can say minus 5 by 10 is minus half plus root 5 by 10. And the other root is minus 5 by 10. That's going to be minus half minus root 5 by 10. So I can write the roots as minus half plus root 5 by 10 or minus half minus root 5 by 10. Now, of course, if you know the value of root 5, you can substitute the values of root 5 and then get the root, or you can just leave your answer over here. So it is definitely preferred to leave the answer like this as compared to this form, but I just wanted to show you an alternate way. So the colored form is definitely the preferred form. So you can leave your answer right over here, and that should complete the roots that are given. Though you can also do it this way, but it's better to leave it like this. So again, I'll pause for a minute before I move on to the next one. Moving on to the next question. So the next equation that we have to solve is x square plus 4x minus 1 equal to 0. Again, if you compare, the coefficient of x square is 1. So we get a equal to 1. The coefficient of x is 4. So b is equal to 4. The constant is equal to minus 1. Right? So c is minus 1. So now I can substitute these values of a, b and c in the formula. And I get x equals minus b, that's minus 4, plus or minus under root of b square, that's 4 square minus 4 into 1 into minus 1, divided by 2 times a, that's 2 into 1. And therefore x is equal to minus 4 plus or minus under root of 16 minus into minus is plus, and 4 ones are 4 divided by 2. So therefore x is minus 4 plus or minus root 20 divided by 2. And now I can write this as x equals minus 4 plus or minus root 20 is 2 root 5 divided by 2. So x is therefore going to be minus 4 by 2 is minus 2 plus or minus 2 root 5 by 2 cancels, and I have root 5. And therefore I can say the roots of the quadratic equation are x equals minus 2 plus root 5, x equals minus 2 minus root 5, right? So these are the roots of the given quadratic equation. And again over here, just to summarize, we found the values of a, b and c, and once the values of a, b and c were found out, we just substitute those values in the given quadratic formula. Just be sure that you account for the signs. For example, here if you notice, I had a minus sign and the minus sign. So minus into minus gave me a plus, and this is how, and then I converted the square root into a proper mixed surd, right? So 20 was written as 2 root 5, just to show you that root 20 can be written as root of 4 into 5, and that's going to be 2 root 5, right? So I wrote root 20 as 2 root 5, and then I took 2 out as common, and that 2 cancelled out the denominator 2. Or you can also view this as minus 4 by 2 is minus 2, and 2 root 5 by 2 is just root 5. So the roots of the quadratic equation are minus 2 plus root 5 and minus 2 minus root 5. So again, pausing for a minute before I give you some questions to solve on quadratic formula. Okay, let me now give you a few questions to solve using the quadratic formula. So these are the questions for you to solve based on simultaneous equations. I am going to hold the screen for another 5 minutes, so you can copy all the questions or take a snapshot. And I hope you understood the application of the quadratic formula in this particular session. And this basically means the variable here. Okay, solve for the variable using the quadratic formula. So whatever the variable is, you have to solve for that. And in the next segment, we will discuss more about the nature of roots as well as some more problems on quadratic formula. Okay, so we conclude today's session here.